Well, on Tuesday, Bruce called me to say sadly, Richard Corbett has had a bad fall, who normally does Sky this month, and so we wish him well, if he gets better soon. But he asked me to do it, so I shall do my best. As well, you've mentioned that obviously we've all seen Saturn, Jupiter, which are very prominent right now. So I thought just look at a few interesting topics. The first one that you can see with the naked eye is on November the 13th. The moon is going to line up with Castor and Pollux. So actually it depends on the time of the evening, but well, as the moon rises, they're pretty much in straight line. They're about a finger's width apart. But the moon, which is something interesting, which actually came to our attention when Bruce mentioned that Jupiter was directly above the moon a week or so ago. And I sent him a picture about 11 o'clock at night, and of course it was not above the moon. It was a few degrees to the east of it, and to the west of it. And it only really occurred to me then that if you divide 360 degrees by 28 times 24, it actually moves about half a degree. In other words, it moves about one moon width per hour against the background sky. So that's how it got out of alignment. Anyway, that's something that you might look at, something easy to see with the naked eye. Castor is well, they're both double stars. Pollux is a variable star, and Castor is actually it's a bright star. It's a sextuplet system, which you obviously need a telescope to see, but you should see that alignment quite comfortably just with the naked eye. The next thing is this month, well, assuming we see anything, because of course mostly cloudy, but is the Leonids will come up, and well, they actually sort of should be prominent for most of the second half of the month. And if you look, that's looking east, and unfortunately they're sort of, you're really going to have to either stay up late or get up really early because they're in the middle of the night. But that's rising actually about midnight on the 17th, and they are the remnants of the Tuttle comet. But it did raise the interesting question: is you probably know they all appear to radiate out from a point, and the question is, why do they do that? You know why they do that? Does anyone know why they radiate out from a point or appear to?
The same way that snowflakes, when you're driving, go all around your windshield.
Well, sort of, yeah, because I mean, it's basically just perspective, because they're all coming. It's a parallel stream coming from a point effectively as infinity. So it's kind of like railway tracks. So you see them appearing to diverge from infinity. So it's, I mean, so that's so anyway, there should be about 15 meters an hour at the peak, which is around the 17th of November. The next thing I thought we'd look at is something to look at with binoculars. And the owl cluster is quite prominent because Cassiopeia, which Michael was talking about, is high in the sky. So, and the Alps cluster is right here. So if you take these two stars, Nevi and Rukba, in the W of Cassiopeia, and make a right angle triangle, you get to the Owl cluster. And then you could see with binoculars, and what it should look like is this. That's a more distant view, and that's this close-in view. And these two stars here form the eyes of the owl. And if you use your imagination, that's its body. And if you use your imagination even more, that's its wings. But that's something you can see with binoculars. And it should be fairly easy to find, because you just go, let's say, if you Cassiopeia is very prominent. And if you just find these two stars in the W and make that right angle, then you will land on the our cluster, and that's tells you about it there on the little blurb. So and the next event is December the 7th, is the occultation of Mars. So this is 5 o'clock on December the 7th, as the moon and Mars will start as they rise. Mars will just start to be blocked by the moon, and now this was actually meant to be an animation, but the thing telling me I'm screen sharing is in the way of where it started, so I'm not quite sure I did it. But anyway, over the course of the next 5 hours, the moon will move along this way, and then at about 11 o'clock, Mars will appear from, by this stage it's going to be up here somewhere. It'll appear at the other side of the moon.
When will that happen, Richard?
This is on the 7th.
Yeah, but so
It starts at 5 o'clock.
And then finishes
about 11 o'clock. And it is, this is actually, I made a video, but I can't find it.
The screen share, you can do the top of the screen.
Can I? Drag that out. Oh yeah, okay. No, it's, anyway, never mind. You take my word for it. It's just an animation. It just goes behind, and it comes. It's about 11 o'clock.
And it just takes, because of the movement of the moon, it's only an hour.
Well, for whatever reason, it's somewhat longer than that.
Unless Mars was moving at the same speed.
It must be something, because either the program is wrong, but it must be something to do with the two moving, because it actually gives it at about 4 or 5 hours.
Yeah, but you just explained that the moon moves
It's moving.
its own diameter every hour.
Yeah.
And so
So
on the
Mars
greatest part, if something is obscured by the center of the moon.
I know, that occurred to me, but I assume it must be the Mars is moving as well. But
It is, but very much slower.
Yeah, well, and this, I mean, this is this has got it wrong, but I actually animated it. I can't show you the animation for some reason, but anyway, 5 o'clock is when it starts the occultation. So yeah. Oh, okay. So the next thing that we have is opposition. Mars orbits the sun roughly once every 2 years. So every other year, it ends up on the far side of the sun, and then the intervening years, it ends up on our side of the sun. So as you can see, these are approximate distances. The distance from the Earth to the sun is 1 astronomical unit, approximately half an astronomical unit to Mars. And so, well, let's just go to it's 1.5 astronomical units out the other way. So it's when it's on the far side of the sun, it's 2 astronomical units away. When it's in opposition as it's coming up on December the 8th, it's closest approach. And if you look at the difference in magnitudes, it's 16 times brighter. It's when it's on the far side, it's minus 1.5. On this coming December the 8th, it's going to be plus 1.5. It's 3 magnitudes difference. If you do the math, it's about 16 times brighter than it was essentially this time last year. So Mars is going to be it's already prominent, and it's going to be even more so as we come up to opposition. The other thing I wanted to point out is the retrograde motion. For a long time, they couldn't understand why Mars seems to sort of gradually move eastwards for 2 years and then suddenly do this little wiggle and go backwards, westwards for a month or so, and then move back again. But it's actually just an illusion, because as we come round on the sort of inside track, as it were, and overtake Mars, it appears against the distant backdrop that Mars is starting to move backwards. And of course, it isn't. It's just carrying on in its happy little way, and it's an orbit. So that's retrograde motion, and all outer planets do it, but Mars is the one that is really the only noticeable one. And then finally, on the 8th, it's about it's going to be about looking south, it's going to be about 63 degrees above the horizon. And you'll be able to find it quite easily because it's relatively close to the moon. So if you want to photograph it, either a red filter or a green filter. The green filter actually is quite good apparently for the dust storms. I haven't tried. I just tried taking a picture of Jupiter recently with a blue filter, which is what's recommended, and it worked very well. But I will try, if I get a clear night, I will try and get another picture of Mars when it's at opposition. I have some of Mars. It'll be interesting to try and get some this time. So that's basically the sky this month.